Good morning, guys. The session will start at 11 p.m. sharp. We have 3 more minutes to go. Good morning, everyone. Welcome to HIW's webinar on significance of wind energy in Indian energy sector. HIW is one of the premium finishing school aimed at enhancing the academic learning of engineering candidates. We provide industry-specific training, helping you in building a career in core engineering sectors. We have around 13 years of training experience and will assist you in inculcating a comprehensive skill set. Okay. Yeah, we have two industry experts with us. Let me introduce them. We have Mr. K. Sridhar Babu, COO of Ecogen Energy, with 22 years of total experience in electrical field, in which he has 18 years of expertise in renewable energy with Cleantech, Lanco, and First Solar companies. We welcome you, sir.
Thanks, Kavya.
Thank you, sir. And we also have Mr. I.D. Pavan Kumar, Managing Director of SP REN Energy Private Limited. He has around 17 years of experience in renewable energy sector, where especially he has experience in wind and solar energy. He has worked in various developers, EPCs, IPPs, and MNC OEMs like Greenco, Vestas, and Mitra. Mitra, welcome, sir. Now, sir, can you hear me?
Thanks.
Yeah. Thank you, sir. We are very happy to have you over here, and I would like to request you to start the session.
Sridhar sir, can you please start the screen sharing, sir? I've just stopped it.
Yes. Is the screen visible?
Yes,
Yes, sir.
Good morning, everybody. Welcome everybody for this great session. basically we would like to give, so an overview of what exactly the role of wind energy sector in the entire Indian energy sector. So as you all quite aware, so basically the entire Indian energy sector, which is consisting of both, so non-conventional as well as conventional fuels, which you might have already studied in your either BTech or MTech when you are doing your graduation or post-graduation. So you must have seen, so the energy sector is dominated by thermal energy, which is predominantly, so from the coal, as well as oil, as well as gas. And slowly, so for the last 10 years, you must have seen an increment in the renewable energy sector. So again, in renewable energy, which you call in your textbooks as non-conventional energy sources. So you must have seen, so growth in that particular sector for the last 10 years. Even, so you have, some chapters related to solar energy as well as wind energy. So what we would like to give, so a glimpse of what exactly the significance of this wind energy. So last webinar, so HIE is actually very, keen in, so sharing the knowledge. So from all the industry experts, and I thank the entire team of HIE for giving this kind of opportunities for the industrialist like us, so to interact with, the student community. So where, so you guys can learn exactly what is happening in the industry, why you need to choose that particular industry or a particular sector. So especially which is a core sector, I'm sure you guys are from electrical or electronics background, which you would like to, so pursue your career in energy or electrical sector. So if you ask me the agenda for this, this is what I'm considering as the agenda. So just wanted to give the glimpse of what is renewable energy and just give what is the total energy mix, the installed capacity, and why we need to go for wind energy. What are the major components of wind turbine, how wind turbine works, and there are various turbine manufacturers. It's not like solar, we have, so 70 to 80 manufacturers in India, but wind is predominantly dominated by large scale, so 4 to 5 manufacturers in the entire country, even in the world also. And we'll also give a glimpse of what are the steps which are involved if you want to construct a wind energy plant. Why wind is driving in India. So these are the glimpse which we will just, so touch upon each and everything in the available time that we have got. So myself and Mr. Pawan will cover, so various topics in this. So let me first, so give, so a glimpse of why exactly renewable energy is required. So, and what do you mean by this renewable energy? So it's actually energy which is produced from the source which is not depleting, means the source is a continuous in nature which never depletes. So the source of energy is like solar as well as wind, where, so like if you see your coal, or you can say your gas or oil. So these are all the fuels which are depleting in nature. But the one which is non-depleted is either wind or solar, which is abundant, available either in country or in the world. So of course, in India, we have tremendous potential for wind as well as solar. So, and other technologies apart from wind, solar is like biomass as well as biogas, hydropower. So these are all the technologies where, so they won't produce any, I can say, the pollution. So if you see the conventional energy sources like coal or gas, so it actually, impacts the climate. So because to produce the electricity, it produces a lot of, so the chemicals which are actually, so connecting the entire environment. So all these non-conventional energy sources basically, so protects the environment and thereby, so the human life. So why, if we want to do, or if we want to go with renewable energy, what is going to happen? If we still depending only on, the conventional energy sources like coal or gas, so first of all, number one, yes, it is going to consume. So over a period of years, maybe another 30 years, 40 years, the resources are getting depleted. So, and the consumption is increasing at the same time, the generation is reducing or the production is reducing. So there's a huge demand supply gap in terms of electricity. So it is the high time for us to look for alternate energy sources, which is nothing but renewable energy. And if you won't go ahead and if you are just focusing only on the coal as well as other conventional sources, it's not only the depletion, it is also impacting the environment. You see the global environmental issues which we are facing in terms of tsunami or earthquake, whatever it is. So there's a ozone layer depletion. So the pollution, which is, so if you go to metropolitan cities, the pollution rate is very high. So and the degradation of the land, air and water pollution, sea level rise. These are all nothing but basically the loss of biodiversity, or so the entire life of the human is reducing because of using this conventional energy sources. So now the wind or solar or other renewable energy sources like hydra, they actually replaces these conventional energy sources, and then they are producing a clean energy which is not impacting any of the climate. So now if you see the installed capacity as on June, so till the last month, so the country has produced almost like 4.46 lakhs megawatt. So if you see the share of thermal, so the thermal coal is 47 point, means the energy produced from the coal itself is 47.3%. Other thermal sources are like your gas as well as oil. So together you have almost like 54% of the generation only from thermal sources. The nuclear as well as other renewable energy sources are contributing roughly around, so the remaining, which is, so 46%. So now, again in this, so I mean, we are really proud of, having the reduction of the mix with respect to the coal and thermal. Because if you see 10 years back, so coal, thermal based coal as well as other sources itself is almost producing more than 80% of the energy mix. So in 10 years, the Indian government has taken enough initiatives to promote the renewable energy sources, wherein most of the companies are also investing in India and promoting this climate change, so by promoting the renewable energy sources. So again, as our today's topic is more focusing towards the wind, so I would like to give the share
Sir,
of,
excuse me.
yeah.
Sir, very low voice, sir.
Okay.
Maybe from
Is
your
this,
side or from my side, I don't.
Kavya, am I audible?
Yeah, you are audible, sir. I think the issue with the other end, sir.
Okay.
You're audible.
Yeah.
Please check your internet connectivity and audio settings, sir.
Okay, sir. I'll check from
Yeah,
my
Ramesh,
side.
sir. Right. Yeah.
Thank you, sir. So now when you go to the distribution of this renewable energy, which is roughly around 1.48 lakh megawatt. So wherein you have almost like solar is contributing around 57.5%. Wind is at this moment it is 32% roughly around, and small hydro or bio, which are contributing to roughly around 10 to 11%. So now if you see both wind as well as solar is contributing to almost like 89 to 90% of the entire renewable energy mix. And that is where, so earlier, so the entire renewable energy industry has started with wind, and slowly the solar has picked up. Now people are talking about, the wind solar hybrid as a combination. Wherein, so the advantage of this combination of using wind with solar is number one, when solar is producing, the production of wind is less. When solar is not producing, production of wind is very high. So a combination of these two is making to use of the entire infrastructure. Infrastructure, I mean the 33 kV transmission line or the extra high voltage transmission line. So in an effective manner. So this is where actually the wind is predominantly increasing now. So I mean, with respect to the solar also, because of so the importance which was given by the government or some of the state governments like Maharashtra as well as Gujarat, they have given so they have come up with a separate policy for wind as well as solar hybrid systems. So now so the state government of Andhra, Telangana are also looking into that, and other states like so Tamil Nadu and Karnataka, they're all looking at say coming up with a new policy by for combining both wind as well as solar, so to make use of the infrastructure in an effective manner. So now if that policy comes, then what happens is, so with a less AC capacity, you can be able to produce more number of units by considering both wind as well as solar. Now, why wind energy? So yes, of course, number one, when you compare with coal or as well as thermal based power plants, which requires enormous amount of capital investment. So first of all, you don't require any input fuel. So your input fuel is wind, which is around abundantly available. Whereas in a coal plant or a thermal based gas plant, so you need to have the fuel, you need to source the fuel, which is coal as well as gas. Availability of the wind in the country, low investment cost when compared to your coal based plants or the gas based plants. Faster commissioning because wind plant, so let's say a turbine can be commissioned maximum of almost like so 5 to 6 months compared to construction of a big thermal based power plant, so which takes almost like 3 to 4 years. So low operation and maintenance cost, so though which has got some mechanical components, but still so the operation and maintenance cost of wind plants are much less compared to your conventional thermal based power plants. Easy to adopt technology. The technology what wind is using is basically it is not at all something which is rocket science. Whatever that we have studied so in our earlier days, which is like kinetic energy as well as so thermodynamics as well as thermal energy, conversion of heat to electricity, conversion of heat to mechanical to electrical energy. So the principles of so your thermodynamics as well as thermal energy is whatever that we have studied earlier is actually so in place right now through in the form of a wind turbine. So that's the reason. So it's always suggested to so go for wind energy compared to so the non-conventional fuels. And the country is heading in the next 10 to 15 years. So the new era is wind solar hybrid systems. So this is what is actually all the states in the country are looking at to bring a special policy for this. So if you see, I mean, of course, Mr. Pawan will give a detailed explanation on the technicalities of wind energy, but I'll just give this one slide explanation. So this is what actually a wind turbine, and so these are so the blades. These are the blades, and then this is what is your nacelle, and so when the wind is blowing, so whatever the kinetic energy which is transforming this to mechanical energy, you have this entire nacelle. There's a gearbox which is inside, and there's generator which is inside, which converts mechanical energy to electrical energy, and it is coming in the form of a cable, which is a 690 volts AC cable, which is coming. So from this, so from the nacelle down, and then you have the transformer which is here. This why we call as so unit substation. So where the transformer associated with switchgear and so which is actually stepping up the 690 volts AC which is coming to 33 kV, and then it is transmitting through 33 kV internal transmission line, and then it goes to a pooling substation, and thereby it is connecting to a grid substation. So the technology wise, so if you see the source of the fuel, leaving the source of the fuel, so it is as good as the common technology which is familiar to each and everybody. So the moment till it comes to the transformer, this is what is an unknown subject. So the moment it comes to the transformer, be it a wind, be it a solar, the entire evacuation system is common, whether it is thermal, solar, or any other kind of energy system, which is like either nuclear or bio, whomsoever it is. So this is the actually the crux of the matter, and the entire research is happening only in producing or I can say in converting the mechanical energy to electrical energy in an efficient manner by reducing the loss. So this is what actually the wind energy or wind technology Now I give it to Mr. Pawan, so who can take care of the basics of the wind. Yes, Pawan.
Yeah, hi. Thank you very much, Mr. Sridhar. So, for brief explanation about the wind industry and then wind energy, turbine, etc. Now, I would like to cover up this there's a technical part where does wind comes from. So, this generally wind is a air motion of air is called as a wind. So this is based on temperature differentiation of in our because of sunlight and other earth rotation, etc. So first of all, like in Earth, we have a equator. Uh, then the most of the radiation falls cover up in a equator and then in tropics. So if you go 1 to 2% of solar radiation that reaches Earth is converted into the wind energy. Like it forms a high pressure and low pressure system. So generally, the solar, radiation and all falls in the equator, and then there it appears low pressure warm air goes to the top of the atmosphere, and then it converted to so it will be sink like in to do the earth rotation and then the equinox of the earth. So it passes through like eastern winds and then western winds.
Sir,
The next slide,
Pawan,
please.
sorry to interrupt you. Your audio is breaking, sir. We'll do one thing. We'll off your video and speak, sir.
Yeah, it's better.
That
Yes,
is better. Yeah, you can continue now, sir. Thank you.
okay. So this mainly actually equal eating of different parts of it. We have most of the heat absorbed in the equator and sinks in the pole area. So it forms actually general circulations. Next slide. Yeah, next slide, please.
Sridhar, sir, next slide, please.
Yeah, this is our general circulation, wind circulations. We are classified into the three circulations. Like first one is a Hartley cells, and then next one is a Ferry cells, and then after that polar waves. So these three circulations you can see in the equator. The low pressure forms at the equator, and it moves upper atmosphere, and then sinks at the middle. I mean, it's a subtropic, and then from there another high pressure system will form there, and it moves towards a pole and raises at the middle of pole. So this one is a Perry cells, we used to call it as, and then after that polar cells above near to that pole there will be low pressure system forms, and then after that it sinks in exactly the northern pole. So these circulations, basically because of solar, rotations and then temperature differences. So it will tend to the east side in the northern hemisphere, and then west side to the southern hemisphere. The next slide, please.
Next slide, sir. Next slide, Sridhar, sir.
Yeah, basically, wind energy is a kinetic energy. The air motion is given it's a power equation for the entire wind. They generally in a wind, it's a power is equal to the cube of the wind. So kinetic energy, as Mrs. Sridhar explained about that, kinetic energy into converted into the mechanical energy into electrical energy. So this is the basic formula: kinetic energy of rho v cube. Rho in the sense it's a density P by RT. So pressure, it's entirely depends upon the parameters like pressure, specific gas constant, air temperature of the particular site or mode. The nest coming to the swept area of the turbine. I'll explain the nest flights. It's a pi r square, area is pi r square, and the wind cube, V cube, is a instantaneous wind. It's a we used to measure as a 10 minutes interval. So this is the driven force, power for the wind energy. Next slide, please. Yeah, coming to the wind turbine technology, do have past 20, 30 years, we have a significant, we do have a windmills. They are having a, like more than 10, 15 blades. And then later on, move to the 2 blades and 3 blades. Now industry is like using 3-blade technology. These are wind turbines. So earlier in 1990s, actually, we do have a hardly like, 200, 250 kilowatt of turbines. Now, past 15, 18 years, we have seen, since 18 years, we have seen 3 megawatt, 5 megawatt, and 6 megawatt, 7 megawatt, and then we moved into the offshore technology as well. So it's gradually increasing the technology. Next slide, please. Next slide. Yeah, wind turbine, as Mr. Sridhar explained, so it's like, wind blows the before the turbine, like, if you see in the picture, inflow wind, it strikes the rotor. These are rotor blades, and then based on the RPM, rotations per minute, it will convert into to shaft. It will go to the generator box. Generator box is with having a different kind of specification. It rotates 1 RPM into the 1500 and 2000 rotation per minute, and then convert it into the generator. Then after that, it will go to the cable. Through cable, actually, we'll step up 33 kV or 11 kV, whatever the different model, and then we will fed into the grid through all transmission line, and then we are using all DP poles, transformers, etc. So this is basically how a wind turbine works, and then I'll show you the different operators of the turbine. The turbine consists of multiple things. Next slide, please.
Yeah, just to add to Pawan, basically this is the place where, so you'll be getting that 690 volts AC output, so the output of the generator is electrical energy, which is 690 volts cable. That cable is actually coming from the top to bottom, and thereby it is connecting to the transformers to step up to the required voltage level, which is either 11 kV or 33 kV. Generally, industry norm is 33 kV. We always step up at 33 kV to reduce the line loss. Yes, Pawan, please.
Yes. So these are all wind turbine component. Basically, mainly, actually, it's a rotor, blades, and hub nose, and then we have like a pitch technology. So it's a variable. In earlier stage, we have only stall regulated. Only it's a on and off blade rotations, like open and off kind of thing. That we called it as a stall regulatory kind of system. And now all turbines are in a latest technology. We have pitch technology. Like, we can vary that blade according to the wind speeds. We do have a wind speeds, it's a varies within a fraction of seconds, or it will be the timeline. There will be like 10 minutes, 5 minutes, 1 minute. We used to call it as seconds also. 3 seconds is called as a gust wind speeds. Sometimes high wind speeds, like 30 meter per second within a fraction of seconds. Those time actually will regulate the entire blade mechanism with due to this with this actually high hydraulic system and all. So next is a drivetrain, which is basically after the rotor. It's connected with the shaft like brake, gearbox. It connected to the gearbox. Gearbox will escalate the RPMs. One rotation per minute, one blade rotation tends to 1500 or 1800 times of RPM, which is connected to the generator box, and then next generator to the transformers through cable, etc. So these mainly all components, like, and forgot to tell you, this air system also is there. Like, the entire wind nozzle will move, like, turn 360 degrees based upon the wind direction. Okay, so it sends, we do have a like sensors on the top of the nozzle. I'll show you the nozzle pictures as well. I can observe the things. So we have a sensor on the top of the nozzle, wind wind speeds, wind anemometer. It measures wind speeds, and another one is a wind vane, which measures the wind direction. So due to that wind measurement, those sensors, wind speeds, and then the direction, it controls the entire wind turbine technology. So yaw system will move, like, based on the direction, and then pitch, like based on the wind speeds, the pitch blade will rotate, and it will give you the exact power. Next slide, please. So just these are the wind turbine components. First one is a rotor. This one is called as a nose, and I explained you like which blades are there, and you have a brake, yaw drive. So all gearbox, long speed shaft, and then these are anemometers and wind vanes on the top of the nozzle. So next, these are main basic components for the wind turbine. Next slide, please.
Yes.
These are wind turbines. In the earlier days, we used to have a lattice structure. This is a lattice pole kind of structure. On top of that, wind nozzle, and then the rotor entire shaft is there. So, I mean, in recent days, actually, we are using the tower, steel tower kind of model. This one is the first one. You can see that steel tower, and after that, lattice plus hybrid towers, so different types of towers. Like, we have mixed up with a lattice and then hybrid tower. And recently, the tower we are constructing, like, this entire concrete tower as well. So next slide, please.
Most widely, just to add to Pawan, most widely, this is what is right now. People are working on this as well as hybrid model. So people are not that going with this type of structure. I mean, in fact, in India, so people are coming with, they are using this hybrid structure, as well as, so the international manufacturers are going with these kind of structures. Yes, Pawan.
Those towers also actually, in earlier days, it is like it was 30 meters to 50-meter height of the turbine heights. Now we have a 120, 150-meter height as well. Towers. These are the blades. The blade length has been 160 meters also. So each turbine having a like a different parameter specification. Based on that, the tower height and then blade length will be defined. So each turbine is a varies. So each capacity like 250 to I mean 3 or 5 megawatt of turbine. So for suppose, for example, 250 meters, we have a blade length of like 40 meters. And then if you go with a like 2.5, 3 megawatt turbines, we have a different length like 90 meter, 100 meter. It is like, we are increasing, means blade length means like we are increasing the swept area to get more wind power. So so accordingly, we'll get a higher power output. Next slide, please. So this one is a wind turbine nose and then nozzle. Actually, on top of that, we do have a like shaft and then nose pitch direction drawing, and this one you can yeah, this one is a nose. First one is a nose, and then all components are placed in the nozzle. On top of that, you can see the wind measurement and then wind vane as well. Is placed on the top of the tower. So wind turbine manufacturers, we do have a like Vestas, Suzlon, Shenyang, GE, Envision, Inox Wind, Global Wind, all are MNC companies. They are past 30 years they're in the industry. They are supplying a different kind of turbine models, start from ranging from 250 to 36 megawatt as well. As well. Next slide, please.
Of which Suzlon is basically the manufacturer. It's a local, or I can say Indian manufacturer. All others are, so manufacturing their turbines outside India. Whereas Suzlon is a purely indigenous company. In fact, Inox is also having their own factory in India.
Yeah.
Yeah. So now, thanks, Pawan. So let me just, give some glimpse of, so what are the steps which are involved in, so construction of wind turbine, or I can say wind energy power plant. So it all starts with, so the identification of the location. So first of all, what you have to do is you have to find out, so which location has got a greatest wind potential, so that you cannot just, judge by just, so standing in that particular location. So what you will have to do is you have to, so purchase a wind mast. A wind mast is nothing but which has got, so the sensors like anemometer and other wind directional sensors. Basically, you will have to install this wind mast, which is roughly equal to the height of your wind turbine. So let us say if you are going for nowadays, the wind turbine is almost like 150 meters, 140 to 150 meters high. And all the wind masts are available at almost like 150 meters height, So we have to install the wind mast in the location where we feel that, we wanted to install our wind turbines. So you need to collect the data. So what we need to do is we just have to forget about this wind mast for about a year. And then, so every day, this wind mast gives the data to us, and you have to process the raw data which is given by this all the sensors which are placed in the wind mast. And then after 1 year, you will have to analyze this data, and you have to find out what exactly the wind speed in that particular location. So as well as in which direction the wind is predominant. So if the wind speed is much beyond the cutoff, then we use that, so wind data, what we have collected through wind mast, and we do a wind resource assessment. Basically, it's equal to, so what we generally call as yield estimate or the yield analysis. So means with that particular location, if I install a wind mast, how much energy that it is producing. So that is what is the outcome of this wind resource assessment. Let us say, is it producing a PLF of, so 32%, 35%, or 40%? In turn, how many units that it is giving per annum to us? So that is what we call as wind resource assessment. So generally in most of the locations, so the wind resource assessment is almost like, the wind turbines are giving a PLF which is roughly in the range between, so 37 to 41%. So wherein if you see in AP, so we have a good predominant zone, wind zone, which is like, so in Kurnool as well as Anantapur. In that entire belt, we have, so good wind energy. So it's basically it has got almost it is giving a 38 to 39% PLF. So in actually AP as well as in Maharashtra areas, even in Karnataka. So that the PLF is very, very important, so for us to make a decision whether to invest in that particular location or not. Because so if the wind, if the generation is very less, so and thereby it won't so give us so the returns that we wanted, because almost every company is ultimately the objective of the development of any power plant is so how the returns are, so if in the region, if the wind potential is very good and it is giving more kilowatt hours, then the returns are very good. So once you have the wind resource assessment, then so yes, now so this is the particular location where I wanted to have the wind turbine in place. Then you look for the data, the land documents. So because you need to first acquire the land before you place the wind mast, right? So you need to first collect all the land documents. So roughly for a turbine of a size like 3 to 3.5 megawatt, you require an area of around 6 acres of land. So a 6 acres of land is required. So so you need to collect the land documents, and you have to so do the later legal due diligence. Once the legal due diligence is completed, then you can go for a registration of the land, so in the name of the company. So and then afterwards, so you start working on your foundations, so you have to cache the foundation, and then once the foundations are completed, then you start working on erection of the turbine. So first, so you erect the tower, and then so using a crane, as well as so hydra, you will have to lift the nacelle as well as nose, and then all the blades you have to lift it and you have to place it on the top of the tower. So that's a critical and a high risk job. So basically, so by any chance, if because in the entire wind turbine, nacelle is the heart of the entire system. You must have seen, like as Pawan has explained, the nacelle has got the gearbox as well as so your shaft as well as your motor. The whole conversion of the mechanical energy to electrical energy is happening only in the nacelle. So which is a very important component in the entire wind turbine. So this nacelle building and so lifting the nacelle and placing on the top of the tower is actually a critical crucial job. So and that has to be done with the help of so 2-3 cranes, and under the supervision of so good safety team. So once the wind turbine erection completes, then you will have to so build a 33 kV transformer. So what you have to do is you have to place so you have to place the 33 kV transformer as well as 33 kV transmission line, and then you have to construct a pooling substation where so you will have to pool all the 33 kV lines which are coming from various wind turbines at one location. And then let us say if you are building a 30 megawatt plant, and if you are using a 3 megawatt turbine, then you require 10 turbines. So you have to get the 33 kV line from all the 10 turbines, and you have to pool it at one place, which is what is your pooling substation. And then, so if you wanted to step up to a next level, let's say if you wanted to transmit at 220 kV level, then you have to use a step-up transformer, which is converting 33 to 220 kV. And then you will have to transmit the 220 kV through a EHV transmission line, a 220 kV transmission line. And then you will be evacuating at the grid substation. So from the grid substation, this is actually now the electricity is flowing and it is passing through wherever it is required. So ultimately what we have to do is, once we generate the power, we have to evacuate at the grid substation. And yes, you need to obtain several approvals before you commission the plant. You need to get the approvals from the land department. You need to get the approval from pollution department. So you need to get the approvals from the transmission line, like say your transpo for the synchronization as well as commissioning. So you have to get all the approvals before you commission the plant. Then only. So once you have all the approvals in place, then the transmission corporation will allow you to charge the plant. So these are basically the steps which are involved in construction of any wind energy plant. So as I clearly mentioned, let us say nowadays today, we are having turbines which are ranging from so 3 megawatt to 3.5 megawatt, and I mean people are coming up with 5 megawatt single turbine also. One turbine of 5 megawatt. So if you just use only one turbine, you will be able to produce 5 megawatt. So for the same, to produce the same 5 megawatt, so a solar energy, you require 20 to 25 acres, whereas you can produce the same 5 megawatt in 8 to 9 acres. So so I mean, if you see the difference between so wind as well as solar requires a lot of ground area, or I can say land, whereas wind requires so lesser land. But yes, the issue here is you can be able to place the wind turbine only where the wind is there. So otherwise, there's no point of so placing the wind turbines. So these are actually the constructional pictures. This is where so the foundation. So there is excavation which is happening. So generally, this is roughly around 1 acre to 1.2 acres area. So where you will excavate the entire land, and then so you will go for so placement of the steel, and this is what is your turbine area. So in the ground you will have to use this entire steel reinforcement, and then you place the concrete, and this is what is your base for the tower. So tower base is this one, but ground, so almost you can say it is more or less 15 meters depth, you can, sorry, 5 meters depth you can see, so here. And then once you have the foundation reinforcement, everything is done, concreting is done, then this is what is your foundation. So your tower will be placed on the foundation, and on the top of the tower you will have your nacelle, and then blades will be erected. So you can see these are the blades. So this is what is your tower. You have the foundation, this foundation. On this foundation you will first rest your tower, and then you have, this is what is your nacelle, and then this nacelle, all the blades you are erecting using this crane. This is what is a crane, and the crane is used to lift this nacelle and placing on the tower. So, and these are all your 33 kV transmission lines, where which is carrying the power from one place to the pooling substation. So just these are like, it's a 33 kV switchyard, 33 kV transformer, and this is a DP switchyard. So double pole switchyard, where you have your isolator and other equipment and metering. So this is a typical wind farm. How a wind farm looks like. Yes, Pawan, please.
Yeah. Yes. Thank you.
So,
Thank you.
I mean, we will just give, the requirement of why wind, so just, so in our few words. Yes, Pawan, please.
Yeah. Hi. Thanks. So wind energy is driving in Indian energy sector now. So the first point, there are like 10 scenarios. First one is a rapid capacity expansion, the Make in India program. And then the government of India has placed a target of like 140 gigawatt by 2030, sorry. And then net zero emission by 2070. So based on that, like the capacity has been increasing, like till date, as Mrs. Sridhar said, till date we have achieved almost 150 gigawatt of renewable energy sector. So this is based on a different scenario, and then we are meeting the targets of government MNRE and then government of India. And the next point is like government policies and initiatives. Now, Indian government has given a renewable purchase obligation, which is to the commercial and C&I customers. We used to call it as commercial and industry consumers. They have to install green energy sources of power. And the capacity for their consumption. Minimum, the government of India, they have targeted like minimum 5 to 10% respect to states. So minimum they have to have a 5 to 10% of green energy consumption of green energy power consumption for different states. They have and then they were given a captive or group captive model, and it's like competitive bidding process and third party open access model. Also, they have given a different policies and the initiative for having a green energy sources. And the next point is technology advances and domestic, as you said, like it's a Make in India program. Nowadays, everybody is coming up in the manufacturing sector. We are depending on technology upgrading, like in a wind energy sector, technology partnership with some foreign companies, and then we are manufacturing in India itself. We have a manufacturing base of producing like 1.5 gigawatt per annum. Next slide, please. Next slide, please. There we go. And the next point is economic growth and job creation. So, job creation at various levels. Like we do have a wind resource assessment starting position. It's a crucial part. And then later on, for as we have seen in the project snapshots, like excavation works, and after that, steel bar bending and local skilled laborers and unskilled labor we will use. and it is a bring like it brings like infrastructural development to remote areas, and we have a um, like road also pathways are required, and the road construction, a lot of indirect and direct job creation from this industry sector, and increasing investment. We then recently government is having a like they're encouraging FDIs, foreign direct investments, and then they're encouraging their create allotting so budgetary on this green energy, especially wind energy and then solar energy, like from the PFCs, like Power Corporation of India, and then IRIDA pension funds. They're allowing then allotting the budget as well. The cost competitors, like in a nowadays, like wind energy, they are like government is buying wind power and solar power with in a very competitive bidding prices. So according to that, we have this cost competitiveness, like altering the some manufacturing and economic scale, etc. Government incentive, we can take it as like power by different alternative generations. Next slide, please. This is a wind energy is like environmental benefits, like reducing carbon emissions, greenhouse gases, and mitigating air and water pollution. So mainly sub-zero pollution, and there's no input power sources for this. So it's an environmental benefit to reduce global warming and the climate changes. So supportive infrastructure, government is providing the national grids and dedicated grid infrastructures. They are providing a good like central power grids, transmission capabilities. Especially they have given a green energy corridors. They're selecting some multiple states, like where we have a good potential resources and states. They're choosing it as like green corridors. There where they're creating infrastructure to connect the wind power and renewable energy sectors. And the last point is global leadership. Like as we have international collaborations and Copenhagen, Paris, climate change, and we do have some target net zero, carbon net zero carbon global and other policies, etc. Practices. Generally, we have climate change policies, and then practices we are adapting, and we are making like targets like 500 gigawatt of green energy sources, and mitigating the all climate change, global warming, carbon emissions, etc. So this is what how Indian energy driving gas sources. Next slide, please.
Yeah.
Oh, okay. Thank you. Yeah. Any questions, please? Question and answers.
Sir, before we take up any queries of the students, I would like to tell about our job-oriented course, which is which is starting on 23rd of September. But before giving a detail about this, Sridhar sir, can you please stop the screen share?
Yeah.
Yes, sir. Yes. Thank you so much. So, guys, we have a job-oriented course for all electrical engineers where we provide you training, technical training, and also soft skills training. The new batch is starting on 23rd of September. Okay. The course details, everything will be shared. Will be shared on the chat box. Okay. And whoever has whoever is interested, you can know about the course by just calling to the numbers that have been shared in the chat box. Okay. And for the queries, we will go ahead. Whoever has queries can raise your hands. We can unmute. We will unmute one by one, and you can speak up. We also have some queries in the chat box. So we would like to go one by one on those things and then take up the people who have raised their hands. We have a question from we have a question from one of our students saying that Bhuvaneshwari saying that where can we get practical knowledge on wind energy generation?
See, basically, practical knowledge, as per my knowledge, is so the design engineering base, the concepts and all, of course, so definitely in the institute you guys will teach. Maybe during the construction erection, so one of the turbine locations map may be shown, depending on so the permission center. But practical knowledge is, practically you will be able to so learn the entire design process. So but implementation, yes, so unless you get into the company, you will not be able to get the practical knowledge.
Yes, also we have one of our students raising our hands. So I'm asking them to unmute. Sugumant. Can you please unmute yourself and speak up? I've given you the permission.
Very good afternoon, madam. I am D. Sugumaran of third year triple department.
Yeah,
Yes,
go
I am
ahead.
hearing,
Please
madam.
speak up. Yeah, we can
Madam,
hear
I
you.
am
Go ahead.
now pursuing third year triple E. I am also interested to study the HIEE courses. I am eligible
Yeah,
for that.
yes, you're surely eligible, and we will contact back. You can contact us on the numbers that are shared in the chat box, and you can absolutely take up our job-oriented course.
Madam, it is paid or non-paid classes?
It is paid. It is paid, and it is a training plus placement course. All the details regarding the course will be explained one-on-one. Okay.
Guys,
Madam,
Sugumaran,
to know more.
Sugumaran, thank you for your query. The queries will be regarding the training batch will be answered separately at the end of the session. Right now, we will only take up the technical questions regarding to the respective session. So we had a question from Suresh Babu Ode. Does wind turbine rotate both sides if any restrictions? So the answer has been given by Pavan Kumar, yes, 360 degrees. And we also had two more questions at the start where we were discussed or we were asked with the questions on.
There's Akash Gumadi asking for how is the job market in wind energy generation?
Sridhar sir or Pavan sir, would you like to answer the question?
Yeah, of course, so at present, so be it any renewable energy, so it's actually dominating in the industry, be it a wind or be it a solar. So enough engineers are required, but there are no manpower which is available who has got good concepts in wind. So the institutes like HIE will give basically the concepts related to wind and solar, and those will be useful for you guys to get into any wind company. There's a huge potential for requirement of wind engineers or the solar engineers right now. And it will last for the next 10 to 15 years.
Yeah, we have one more question from Sushant Patel saying how the direction of turbine is decided. It's anti-clockwise or clockwise direction, and what will be happened with wind direction and the turbine?
Yeah, see, Mr. Sushant, like as I told you, there is one sensor placed on the top of the nozzle. With that sensor, it measures wind speed and then wind direction. Those sensors connected into the control panel unit of the turbine, and which is the direction is, if it is not like a direction clockwise and anti-clockwise direction. Based on the direction, a wind vane measure based on the direction of the wind main sensor, it turns into the towards the wind blowing area. Before that, predominant to the direction, like before that north and whatever. Uh, it will be like in a fraction of second, it will change the direction as well. Like if it is like comes to the west, let's say example, west towards predominant to the west, and after that, within a fraction of 10 minutes or 15 minutes, it will changes. Abruptly, it will change wind direction, and immediately my sensor will sense the direction and it pass into the control panel. Slowly, that wind nozzle, entire nozzle will rotate towards the predominant direction. It's not like depends upon anti-clockwise and anti-clockwise.
Okay, sir. Thank you.
Okay. Thank you, Sushant, for the question, and thank you, Pavan sir, for the answer. We have one more question saying that how much wind pressure is required to rotate the turbine?
There will be like the power with respect to wind speeds. We used to calculate based on the R&D R&D segment, like it's like turbine manufacturer used to give the power curve, which is like it's a ratio between wind speeds and then power. Present we required minimum cut-in wind speeds for latest turbine technology, like 3 meter per second and 3.5 meter per second. It starts from 3.5 meter per second, and slowly it increases to up to the certain level of wind speeds to get more efficient power from there onwards. And it starts from it will stop after certain cut-off wind speeds also. The turbine, like the driven technology, like 3.5 meter per second in the cut-in wind speeds, and it reaches up to like 11 and then 11.5 meter per second to attain more power. After that, there will be a cut-off wind speeds like 25 meter per second. This is how the power curve defines in the R&D sector.
Okay.
This
Okay.
OEM is to give the power curve and then thrust curve for wake efficiency.
Right. There's another question from Manohar. Is there any DFIG wind turbine installed in India? Can you please give the answer?
Yeah, DFIG wind turbine installed in India. It's in they have installed in the Gujarat area. As of my knowledge.
Okay.
Yeah, I think it was installed in Gujarat area.
Yeah.
Yes.
Yeah,
Mission.
we do
Not
have,
many have installed. I think very few are installed, mostly in Gujarat area.
It's a
okay.
manufacturer like Inox, I think so. Manufacturer. Yeah.
Okay, thank you, Sridhar sir and Pavan sir. We have one more question from Amar saying, how do the aerodynamic efficiency and structural design of wind turbine blades impact the overall energy conversion efficiency of windmills, and what are the engineering trade-offs involved in optimizing these factors?
Mm.
I
Aerodynamic-
think we can take the question,
this-
sir.
Yeah.
Yeah, this one is okay.
We can break the question. We'll first answer the first part. How do the aerodynamic efficiency and structural design of the wind turbines impact the overall energy conversion efficiency?
Okay. See this one, like wind power from the basically theoretical wind to electrical power. There is a as per the bench law, we can extract 59% of the 59% of on total theoretical wind as per the bench laws. Like conversion factor is 59% only. It's entirely depends upon the blade, rotor area, swept area, and then is there a pitch angle, or at a variable speed. It's entirely controlled by the turbine manufacturers. Okay, OEM will give the power curve and with respect to wind speeds and thrust coefficients, etc. Based on the research and development, the turbine will automatically calculates the variable wind speeds and changing the pitch direction, yawing, etc., etc. I mean, it's a detail we need to have
Yeah,
a
basically,
detailed.
I think just to add to Pawan, there's a lot of theoretical calculations which are involved in the controlling, as Pawan rightly mentioned. So every factor is playing a very important role in dynamic control of the entire motion of each and every blade. So thereby connection or rotation of the gear. So it's not that simple. It's a huge theory which is involved in it. Yes, next question.
Okay, sir. The second part of the question is, what are the engineering trade-offs involved in optimization of these factors?
See, at present, so most of the engineering is happening in terms of increasing the height of the turbine, as well as increasing the rotor dia of the turbine, thereby capturing more energy. So earlier the turbines are producing, so 20 to 25% PLF. And, it is now today, so if you see from the last 12 to 15 years, the PLF of, so the wind turbine has moved from almost like, so 20%, 90 to 20%, to almost like 41 to 42% as on today. So most of the optimization is happening how we can capture most of the wind, so by rotating the turbine, as well as, so by increasing the rotor dia, as well as by increasing the height of the turbine. So, and also the conversion efficiency. So the conversion efficiency when you take from, so the mechanical energy to electrical energy. So which kind of gearbox that we can use, and what are the new technologies, and so a lot of research is happening in, so increasing the conversion efficiency, or indirectly I can say reducing the loss of conversion. So the optimization is happening in the entire area. So these are all the areas where a lot of optimization is happening, where, so number one, to increase the I can say increase the productivity, or I can say number of kilowatt hours, at the same time reducing the overall cost of the turbine. So these are the optimization points, and a lot of engineering is happening in this direction.
Okay, thank you, Sridhar sir. We had a hand raised by Mr. Mohammad Margoob. Can you please unmute yourself and ask your question? You're there, Mohammad?
Hello, sir. Sir, you talked about the integration of wind energy with the solar energy. My question is, what are the challenges in integration of wind energy with the solar energy?
There is no challenge. Both are two different sources. You are just, so connecting one, you are bringing 133 kV cable from wind, you are bringing another 33 kV cable from solar, and you are connecting to, transformer. There is no challenge at all. As on today, there is no challenges, and it is already implemented. In Gujarat, so they have already come up with a policy, and then they have implemented. Now, in other states, so people are trying to come up, because basically it's a policy driven subject. There are no technical challenges here. It's only policy driven challenges. So now the government is looking at implementing these policies. Once the policy is in place, of course, we can also go for wind and solar hybridization. There are no technical challenges at all.
Thank you, Sridhar sir. We have one more question from Venkat Sai saying that, is it possible to place wind energy system for vehicles like as solar for energy generation?
Is it possible to, sorry, can you repeat?
Is it possible to place wind energy system on vehicles, as in we like place solar panels for vehicles to work?
I don't think it is possible. Earlier, see, the wind energy in India has started with very small wind machines. Like, so on the roof, you can place a wind machine, roughly around, so 2 kilowatt, 3 kilowatt, so wind machines. So if you see in 2000, 2001, 2002, 3 kilowatt or 4 kilo of wind machines have come up well. But so because of lack of maintenance, and and the height limitation, what happens is if you are keeping that in the roof of any of your building, so you require so the wind, right? So, and there's a lot of obstruction from the nearby buildings, and those machines are failed. So, and that is where this has moved to a free zone. Wherever the land is available, there you can put up a high rise wind machine, and then you can get the energy. So maybe in the future we will have to see if at all any technology advancement comes, but I did not foresee anything related to that at this point of time.
Right. Thank you, Sridhar sir. I see that there is a very good discussion happening over the chat box on the question posed by Yashwant regarding the color of the why wind turbines are in white, why not other colors? Wind turbines producing AC or DC. So thank you, Vikram. Thank you, others speaking on why the color is white and all. Thank you, Manoj and all. So I think we have another question from Venkat Balaji saying that what is the role of wind energy in reducing greenhouse gas emissions?
Of course, so wind technology, I mean, see, every kilowatt hour that you are producing, every kilowatt hour that you are producing from any of the non-conventional energy sources has got a direct impact on reducing carbon footprint. So reducing carbon footprint is nothing but you're reducing greenhouse gas emission. So let us say if you emit 1 kilowatt hour, there is an equivalent of reduction in the carbon. Let us say an equivalent of thermal. If you release 1 kilowatt hour from a thermal power plant, you need to produce or you need to release some gas, greenhouse gas, and which is nothing but a carbon. So it's a carbon gas, and that actually is not happening when you go with any of the non-conventional energy sources. So indirectly, a production of each and every electricity is proportionate to the carbon emission. So you are reducing the carbon emission by increasing the production of kilowatt hours from non-conventional energy sources. So there is a direct relation between so the kWh which is producing from these sources vis-a-vis the greenhouse gas emission.
Right. Thank you, sir. That's a good answer. I mean, yes, when you look into your impact of wind energy onto the greenhouse, it is obviously a clean energy, so we will not see anything, and we're not burning any fossil fuels to reduce any greenhouse gases. Hope we answered your question, Balaji. And then we have Venkat Sai asking a question. Is it possible to place a wind energy system for vehicles? I think this question has been answered. And what is the role of wind energy in combating climate change? Question from Mohammad Abdul Rahman.
Same, so greenhouse gas emission, climate change, all are equal related terms. The moment you are saying that you are not producing any carbon, obviously then you are saving your mother earth, right? So which is what is climate change that that is happening indirectly.
Okay.
Greenhouse gas emission, climate change, all are carbon emission, all are related terminologies.
Right, sir. Then we have another question from Amar Nagar Goji, where he's talking about why can't a windmill convert 100% of wind's kinetic energy into mechanical energy?
Because wind is not a constant source, right? So you will not get the same wind speed, so from morning to evening or even to 24/7. At some point of time when there is no wind, it is zero. So your production is zero. When, as Pawan rightly mentioned, the cutting speed is minimum like 3.5 meters per second, and then it goes on increasing. So yes, Pawan, you can add. Yes.
Yeah, we won't get continuous wind speeds from 3.5 to 3.1 is a cut-in wind speed. It varies from 0 to 3.5. So once this wind speeds attains 3.5 minimum 3.5 meter per second, then it starts the rotation of the blade and then shaft, generator box, etc.
Right.
So below that, it's zero. Anything?
I hope we have answered the question.
Yeah, yes.
Hence, that is the
We
reason
have
you
one
don't
more
get a 100%
question.
Yeah.
Yeah, sir. We have one more. Thank you for the answer, sir. We have one more question from Shruti saying that when we do a maintenance of a turbine, what is the point at which we consider for well working of turbines?
See, maintenance will happen every 2 months once, so basically the maintenance is mostly at the nozzle level, because that is the place where, so a lot of mechanical parts which are involved, so you have your gearbox as well as you have your drive shaft, everything is mechanically, so moving parts. So where you need to apply the grease, so periodically. So that is a place where you need to make the maintenance. Rest like your transformer, your transmission lines. So maybe once in a 3 months or so you will do the maintenance. But turbine nacelle side, at least once in a 2 months you will have to apply the grease and all. But nowadays, so even you need not go up, so to put the grease. So automatically the transmission system will, so put the grease once you place the grease, set one location. So even for maintenance also, you need not go on top of the nacelle and then do the maintenance. You will have to reach there only if there is a issue, and then if the turbine is not functioning, then only you have to go. Otherwise, the maintenance wise, like once in a 2 months, you can do the maintenance.
Thank you, Sridhar sir. We have a question from Sheikh Shahul, where he's asking, may I know the overall cost of wind energy generating station of construction?
Overall cost is roughly per megawatt wind is costing around 9 crores. So 9 to 9.5 crores per megawatt. This includes your entire land as well as turbine and associated transformer, transmission line system, cooling substation, and grid substation, getting all the regulatory approvals. So all in all, it is almost like 8.5 to 9 crores you consider, so per megawatt as a thumb rule.
Okay, thank you, sir. There's a question from Rajesh asking, would it affect the birds or bats which fly? Will the wind turbines wings would affect them, or is the question?
Very rare, because so the turbine is almost like 140 meters height. So the chances of bird clashes are very less. But once in a while, it may be a, so I mean, I have not seen that, but it may be, but it's not often. It is very rare, I can say. Yeah,
Okay.
Pawan, you can add to me.
Yeah. So negative, I mean, like other impact of birds and etc. Right? They're asking about.
Yeah.
So
Bird collision to
the
the
bird
blade.
collision, and then I think actually it's a very less, it's 140 meters. So then
Yeah.
yeah.
Okay. Before we answer the other questions, as a small announcement, guys, we have shared our certificate link on your chat boxes. Please, I request everybody who's attended the session could give your feedback to know you and to get the better webinars for you on the future sense. So please do give your feedback, and if you have any other technical questions, you can also put it. Considering the time constraint, we would answer 2 more questions that are left. Okay, please give your feedback, everybody. We have question from Aditya asking, wind energy and solar energy are not harmful to environment, but while manufacturing those solar plants and wind turbines, which produce any harmful gases to environment?
Sorry.
Okay.
Can you repeat once again?
Yeah, the question is, we know that the wind and solar are clean energy, but manufacturing wind turbines as well as solar panels, do we have any harmful gases to the environment?
No, nothing. Basically, solar panel is coming from
Silicon, yeah.
So which is of course you are all using, in your laptop, in your desktop, everywhere you are using IC, which is again a so integrated circuit, basically a product of silicon. So solar panels are from, the cells are manufactured from silicon. So yes, so you will have to so dispose after the usage. Let's say once the 25 years of the solar plant completes, or the panel life completes 25 or 30 years, you have to dispose it properly. So that is the one which we'll have to do. to protect the environment, but to produce that, there are no greenhouse gases emissions.
Right. So the last question for the today's webinar: what is the energy storage method used for wind energy?
It is the same battery supporting BESS, battery enabled storage system. That is the same storage system, whether it is for wind or it is for solar. The best system is same. There is no change because whatever the output voltage that you are getting from either wind or solar. So from wind you are getting a 690 volts. From solar is roughly around 600 or 680 volts. So and then you are converting that into 33 kV and you can store it in a battery. So basically, like it is the concept of storage system is same. There is no change in the storage, or there's no different storage system for wind as well as solar.
Right. Thank you, sir. Guys, I have seen that many of you have many more questions regarding the session, and that too, most of them are talking about the solar also as in part of it. To get a detailed information, we request you to join our course to have in detailed information. Kavya, could you please help them out with the batch details?
Yeah, please. So we have a batch starting from 23rd of September. The course is on electrical system design, where we have 11 theory modules and 7 software modules. You can take up this course in online mode or offline mode. Okay, the unique qualities of this course is that you will have this course in 2 modes. You will have recording access, which is for lifetime. You can listen to the recordings n number of times, and you will have 100% placement assistance, where you will be given opportunities to attend interviews, and you will also have a tailored fit program for clearing your interviews. You will be having sessions on resume, LinkedIn, mock interviews. All those things will be done, and then you will be put on to placements also. You can take up this course by contacting the details that are shared in the chat box. Okay, we can have a one-on-one conversation, and you can register on this. It's a paid course, but it will benefit you because we have technical guidance and the soft skills guidance over here, where you can make your career in electrical field. That's about our course. And
adding to Kavya's word, as she mentioned, it's about the various aspects of the course and all. Please do understand we are trying to add upon the wind as in part of into our curriculum in the coming batches. So people who are interested to learn about wind as well as solar in depth and the other factors, do visit our website and our social media platforms to know us better. And the placement assistance which we told is only for the fresher students, and the experienced guys will be given up the reference with respect to their experience. The details about the cost and all, please do talk to our team members, and you can visit our website and all, Manoj. We would like to end the session here considering the time constraint, and most of you have got, and we wanted this session to be purely a technical webinar rather than having an batch discussions. So thank you so much, Pawan sir and Sridhar sir, for your valuable time and effort in making these people understand the wind aspects, and then considering it to be a good webinar session. It was really interactive, and people who have any questions could obviously post us. We are available, and we are always ready to answer your queries.
And you can please, yes, sir. You can please, if you have any more queries, you can keep those queries in the chat box, okay? And any other queries regarding the course would be answered through call. You can call us. And thank you, Sridhar sir and Pawan sir, for having this great interactive session. And I would also appreciate all the candidates who have attended the session and made this session very fruitful. Thank you. And we HRW are signing off.
Yeah, thank you all.
Thanks everybody.
Please give your feedback. That would be helpful us. And guys, you have given your feedback and leave the session. Thank you so much. See you next time.